Welcome to another classroom of distance learning with me, Mr. Biza. Alright guys, so we're going to continue talking about area like we did in the last lesson, but this time we're going to be talking about composite figures. So composite figures are when we have a shape made up of one or more shapes, or made up of two or more shapes. So composite figures are combining two different shapes and putting them together. We find them, composite figures, by either adding shapes together, or subtracting the area of each of those shapes. So we can have a bunch of different shapes added together, or we can have one big shape and take little pieces out to make our composite figure. So let me go ahead and write all these definitions down. Alright, so we got to remember they're made out of two or more shapes, and then we can either add shapes together to find the area of our composite figure, or subtract the area of each of those shapes to find our area of the composite figure. So in this problem I have right here, I've drawn a house, and I have to look at this composite figure. Am I taking out another shape, or am I adding shapes together? In this case, I look at my different shapes that I see. I see a rectangle, and then I see a triangle. So what I'm going to do is I'm going to add both those together. So I first saw my rectangle, and then I saw a triangle. So when I'm seeing these two different shapes, I'm finding the whole area, so that means I'm going to be combining them, which means I'm going to be adding them. So we're going to add those two shapes together. So my first step when I'm finding these problems is I want to know first, like we figured out, is the shape. What shapes am I adding? My next step is I'm going to find the formulas that I'm going to use to figure out the area of each one of these shapes. So the area of a rectangle is base times height. And then the area of a triangle, like we did in the last lesson, was 1/2 of base times height. Now I'm going to go ahead and substitute and solve. So I'm going to put substitute, sub, and solve. Alright, so that's my last step. So the area for my rectangle, this is the first one I'm going to find. The base of my rectangle, so the area of my rectangle, I'm going to use the base. I like to think of the bottom as my base. So 9 feet times the height of my shape was 8 feet. Okay, so now we're going to do 9 times 8. Do some simple math. I use my fingers. I get 72. So the area of the rectangle is 72. And then my units, feet times feet, meaning it's going to be feet squared. Now I go over to my triangle. I know the area of my triangle is 1/2 base times height. The base of my triangle, well, the bottom right here matches the bottom right here. So I know my base will be 9. So 1/2 of 9 feet plus, how tall is this triangle? Well, the whole thing is 12 feet. I knew my rectangle was 8 feet, so what I'm really trying to figure out is what is this last piece right here, this piece right here, to get me to 12 feet. So if I already have 8, how many more do I need to get to 12? Let's see, 8, 9, 10, 11, 12. I need 4 more. So that's going to be 4 feet. So that means the height of my triangle is 4 feet. Ooh, I'm running out of space over here. And we were multiplying, not adding. Alright, so now our area will be 1/2 of whatever 9 times 4 is. 9 times 4 is 36, and half of 36 is 18. And then my last part is feet times feet is going to be feet squared. So the area of my rectangle was 72, the area of my triangle was 18, and like we said at the very beginning, we're going to add those two areas together. So my new total area is 18 plus 72, that makes 90. And we're just adding those feet squared, so it's going to stay as feet squared. All right, so now that's when we're combining two shapes. But sometimes when we have composite figures, we can take out a shape. So let's go ahead and look at an example like that. Let me go ahead and get a new piece of paper and start off again. All right, so here's the new problem. So when I'm thinking about these kind of shapes, I'm going to remember sometimes composite figures have overlapping shapes. And in these kind of problems, we just want to figure out what is the shaded part of our shape on here. So I got to remember, my first step is I got to remember what shapes are we using. Then I got to remember the formulas of each of those shapes. And then my last step is to go ahead and substitute and solve. And in this case, when we substitute and solve our solutions, we're going to subtract to figure out the shaded part. So the first shape I want to figure out is, well, the whole thing. What shape is the whole shape? Well, all the biggest shape I have right here is that square or rectangle on the top. So a square is just a special rectangle, so I'm going to use the formula for a rectangle. Even though it is a square is just a special type of rectangle, so I can use the formula. Then the part that is white, that's the piece that I'm going to take out. And what shape is that white space? Got three sides. It's a triangle. So what I'm taking away is that triangle piece. So I figure out how much is the whole rectangle. Then I take away that little triangle piece, and whatever's left over is going to be my answer. So for my formula, I'm going to do the area of a rectangle. And the area of my rectangle is base times height. The area of a triangle is 1/2 base times height. And now I can go ahead and substitute and solve for this shape. So the area for my rectangle is the one I'm going to do first. So the area of the base was 9. The height was 9 meters. So we're doing 9 meters times 9 meters. So now for my solution, I'm just multiplying. What is 9 times 9? So the area of 9 times 9 is 81, and meters times meters will be meters squared. My triangle over here is kind of the same steps. Area equals 1/2 of 9 meters times 9 meters. So a little bit lucky in this one. I just have to figure out what half of 81 is. So half of 81, if I do my math correctly, is the area equals 40.5, and I'm still have those units, meters squared. So now I'm going to go ahead and subtract. Like we said at the beginning, we have the rectangle. We subtract the triangle, and whatever's left over is my shaded part. So our final total area is going to equal, well, if I subtract these two, I get the same thing, 40.5 meters squared. 40.5 meters squared. And now I found the composite figures of two different styles that we worked on. The part that was taken away and the part where I combined two different shapes. All right, so now go ahead. It's your time to shine. Take it away.